Hi, in this tutorial I'm going to discuss the use of prior information in fruits. And for that I'm going to take this particular model, fruits model, as an example. This is a diet reconstruction problem. So I'll be using the food labels. You could of course use the generic labels. It has no impact in running of the model. But since this is a diet reconstruction problem, I'll stick to the food labels. Okay. Now this is a weighted model, offset dependent model, and concentration dependent model. There is one consumer, 4 food groups, C3 plants, C4 plants, animal and fish foods. 2 source fractions or food fractions, protein and energy, and here by energy I mean actually combined carbohydrates and lipids. And 2 dietary proxies or proxies. Carbon isotopic values and nitrogen isotopic values measured in this consumer. These are the values. Okay. As I said, this is a weighted model, so I'm assuming here that the carbon signal in the consumer, well, 76% of this signal is determined by the source protein, the dietary protein, and the remaining 24% by carbohydrates and lipids. And the nitrogen isotopic signal in the consumer is fully determined by the protein. Okay. Okay, these are the food values, and these are the concentration values for protein and energy for the different food groups. Okay. So let's generate an estimate. Let's see what comes out of this and what we can do in terms of prior information. So let's give it a few seconds. Okay. And so you can see that here there's a considerable amount of overlap between the estimates for C4 plants and animal foods. And let's assume that we have the prior information that the consumption of animal foods was larger than C4 plants. Okay? So, in terms of prior info, we have to go to this list box here, contribution from food groups, and we select animal and double click, larger than C4, double click, add. So it's a list of prior, and then we press apply, and then we can press estimate. As usual, we wait a few seconds, and we will probably only wait a few seconds. So yes, here we are, and now we achieved a much better separation between these two estimated contributions. Okay. Of course, one could use other priors. For example, contributions from food fractions. So the estimated contributions in the diet from protein and carbohydrates and lipids. This is what this energy means, which are given here. So protein 18%, carbohydrates and lipids 82%. Okay. But let's say we know that this has to be actually smaller than 10% for whatever reason. Okay, so protein consumption has to be smaller than 10%. Okay, so these different estimates of contributions, they are expressed between 0 and 1. So 0.1 means 10%. So let's press add. Let's press apply, and let's see what happens if one would apply this type of prior. Let's wait a few seconds and see what comes out. Okay, now we have a reverse situation in which the model is estimating a larger contribution from C4 plants. And the reason is that animal products have a higher content of protein than, of course, the plants. Okay, so let's remove this prior. And now let's assume that we know that the consumption of animal products was, let's say, 30%. So select animals, equal 0.3, that's 30%, add, that's our prior, and then we apply, and then we press estimate. And let's give it a few seconds. And now we should have a very strong prior imposing that the contribution from foods, from animal foods, will be 30%, as you can see here. And the reason for this is that we didn't define an uncertainty for this prior, and so Fruits is using the default minimum uncertainty. Okay. To change that, let's remove that prior. Oh, sorry, made a mistake. Animal. We have to click here on User Defined Uncertainty, and if we do this, we can now define an uncertainty. Let's say 0.05. Okay, and then it has this notation. So you have equal, and then here you have the uncertainty, and then you can write 0.2. If I had made a mistake, we just do this. Okay, equals to 30%, add, apply, estimate. And now we have to wait 3 seconds, and the estimate should be much less precise. And here we have it. Okay. Of course, one could use more priors. Let's say we have the knowledge that consumption of C4 plants is larger than fish. So we could keep this prior and add the next one. So C4 plants larger than, okay, I don't want to add an uncertainty to this. I could. I want it to be a strong prior, so I say C4 plants consumption larger than fish. Press add, and press apply, and now we have 2 priors. And let's see how the estimates look like. And here they are. So considerably more precise in this case. As you can see, okay. And you could continue to add more priors, or you can remove these ones. And Fruits allows you to establish priors for all the 3 different estimates, so the contributions from food groups, or contributions from sources, contributions from fractions, contributions towards contributions from sources towards specific proxies, but also in the parameter values, the values of the direct proxies, the isotopic offset between source and target, the weight contribution values, and the concentration values. And Fruits also allows you to define relationships through different functions. Okay, so you could say that, for instance, the isotopic value of plants is somehow correlated with that of so the carbon isotopic values for plants is somehow correlated with and this is a ridiculous example, with it's correlated exponentially with the isotopic values for C4 plants. So you could build things like this. This is a bit ridiculous here, but just to illustrate the point that this can become very powerful, and you can establish all sorts of different relationships between these parameters, and you can build several of them. Okay, so now it's really a question of having prior information which is valid for your specific problem, and then using it in Fruits, because Fruits has this type of flexibility that allows you to do this. And I hope it's useful. But for now, that is it.